So today is Wednesday, May 13th, and in this video, I'm going to go over your assignment for today as well as answers to the homework that you had from yesterday. So please watch till the end of the video so that you can hear the password for today's new homework assignment as well as get a chance to review for the final test that we have coming up on Friday. So one more reminder, this Friday is your final Unit 6 test. In yesterday's video, I reviewed the vocabulary words and I reviewed states of matter. And in this video, I'm going to review the types of thermal energy transfer and conductors and insulators. So I'm going to be here on the class page in the black folder. I will open up the week 8 slides and then we'll go over the assignments for today. So again, please make sure you watch the entire video today so that you can hear the password. And then a reminder that we have a conference tomorrow. In the Zoom meeting tomorrow, we'll be playing a review game for your final test on Friday. All right, so for our learning objective, it says, I will prepare for the final Unit 6 test coming up by reviewing the types of thermal energy transfer, conductors, and insulators. I will practice for the test by studying the study guide and completing the practice homework number 2. So today you're turning in your practice homework number 2, and if you still want to do the extra credit project, it's due Sunday, May 17th. So the video that you're watching right now will be posted right here if you want to see it again. Remember that you have to watch the entire video in order to help you for your test. So before we go over the new review material, I want to go over your homework that you had yesterday. So yesterday I had you do the test practice homework number 1, and I gave you 3 attempts to do it. Some of the students, they used all 3 attempts to practice, which is really awesome. And I know some of us only used 1 attempt, even though we got a low score. So today I'm letting you know that you're getting 2 more attempts. So in total, you have 5 attempts to practice this homework assignment for your test. And I only count the highest score, so it doesn't hurt to practice all 5 times. You'll do much better on Friday's test if you practice this homework assignment. So those of you who want to keep practicing, or if you didn't get a good score the first time, you can practice 5 times. It's okay. The more you practice, the better you'll do on your final test. So if I go to our black folder, if you want to practice some more, it's right here, test practice homework number 1. And I'm also going to go over some of the questions that we missed. So I saw that a lot of us had trouble with number 2. Number 2 says, when particles are moving around fast, how do you describe their kinetic energy? Remember, kinetic energy is the energy of motion. So if they're moving around fast, that means that they have a high kinetic energy. Just like when you drive your car really fast, the speed that you're going at is very high. It's a high number. Same thing. When particles are moving fast, the particles have high kinetic energy. And then I also saw some students needed help with number 5. The 2 containers of orange juice are the same temperature of 40 degrees. Which container of orange juice has more thermal energy? Remember, thermal energy is the total amount of kinetic energy of the particles. So if there's more particles inside, then it has more thermal energy since the total number would be greater. So the large container of orange juice has more thermal energy. This is because thermal energy measures the total amount. Remember, temperature measures the average amount, but thermal energy measures the total amount of kinetic energy. And since the container has more particles, it'll have a greater number of thermal energy. Now, both containers are the same temperature because temperature, it doesn't matter the size. Temperature measures the average amount of kinetic energy, so it does not matter how many particles there are. All right, and then we're going to also go over number 8. To change from a solid to a liquid, imagine ice being melted into liquid water. Thermal energy must be added. Remember, in a solid, the particles are tightly packed together, but to become a liquid, the particles need to start to spread out. They must start to move faster and have more kinetic energy. So as you add thermal energy, as you add heat to a solid, the particles will start to move around more and have more kinetic energy. And then I skipped number 7, but let's also help you with number 7. All things are made up of smaller parts called particles. Remember, parts, smaller parts called particles. For example, water is made up of water molecules, which are made of even smaller particles known as hydrogen and oxygen atoms. Particles are always in motion and they vibrate. If these particles have low kinetic energy, it means they are moving slowly. If these particles are moving very fast, that means that they have high kinetic energy. Remember, that's the energy of motion. Now, if the blank of an object is 100 degrees, that means that on average, the particles in the object are moving fast with high kinetic energy. So what measures the average kinetic energy? Well, we know that that is temperature. So if the temperature is 100 degrees, that means they're moving fast. Now say that you have a cup of hot chocolate and a large pot of hot chocolate. Both containers of hot chocolate have the same temperature, which means the particles in the hot chocolate have a high kinetic energy. However, the large pot of hot chocolate will have more blank since there are more total particles in the large pot. Now, what depends on how many total particles there are? Well, that's thermal energy. Now, when your cold hands grab the cup of hot chocolate, blank will happen. Remember, when you touch something warm, thermal energy transfer will happen. Thermal energy will transfer from the cup of hot chocolate to your cold hands because thermal energy always transfers from, remember, it always transfers from warm to cold objects. All right, and then last one to help you with number 10. What's the name of the phase change when a substance changes from liquid to solid? Well, imagine like liquid water becoming solid ice. That's known as freezing. All right, so this was your homework number 1 that you were supposed to practice yesterday. If you want to practice some more, you get 5 attempts total. It's okay to practice all 5 times. The more you practice, the better you'll do on Friday's test. So if you want to go back and practice again and again and again, keep practicing. I only count the highest score. All right, now I'm going to go ahead and do our new review for today. We'll be reviewing the types of thermal energy transfer. So remember, we just said thermal energy always transfers from warmer areas to cooler areas. So for example, when this pizza gets colder, that means that thermal energy transferred out of the pizza so that now it's 3 hours later, it's at a colder temperature because it goes from hot to the colder air. Same thing, if your body is warm and it's cold outside, thermal energy transfers out of your body since it always goes from warm to cold. So in this example from the IXL that we've done before, if these two blocks are at different temperatures, how will the thermal energy transfer? Well, block 1, if it's 221 degrees and block 2 is 147 degrees, thermal energy is going to leave block 1 and enter block 2. So block 1's temperature is going to drop and block 2's temperature is going to increase. Now, there are 3 different ways that thermal energy can transfer. You have to know these words. Remember, conduction, convection, and radiation. Conduction involves direct contact, so your hand is touching the hot handle. Convection is the fluids. Hot water and air rise up, cooler fluids sink down. Radiation is these curvy lines known as electromagnetic waves. So again, conduction is when the thermal energy transfers as particles collide into each other. It involves direct contact. When the fast-moving particles touch the cooler particles nearby, it transfers thermal energy and makes the cooler particles also move faster. Now, convection is when the warmer fluids rise up and the cooler fluids sink down. So it's the movement of fluids. So the warmer fluids will rise up and then the cooler fluids at the top are going to sink down. So this happens like when you boil water, when you use the heater at your house. The cooler air and the cooler liquids sink down. The hotter liquids and air rise up. And then radiation is the transfer of thermal energy through space by electromagnetic waves. It does not require matter. So things like when you feel heat from the fire, from the sun, when you use the microwave, all of those things are transferring thermal energy by electromagnetic waves. The sun and the fire, they don't have to touch you in order for you to feel the thermal energy. It's transferring by these waves called electromagnetic waves. So again, please know all three words and their definitions. You must be able to identify them in the pictures and give me examples for your final test. Now, we also learned conductors and insulators, and remember how these types of materials, they can change how much thermal energy is transferred in a system. So the rate, the speed of thermal energy transfer is affected by how well materials can absorb the thermal energy and how well they can transmit the thermal energy. So we learned conductors are all materials that conduct heat very well. They allow thermal energy to move easily through them. So they speed up the rate of thermal energy transfer. So most conductors are made out of metal. So like the metal stove, the metal pan, the hair straightener, the metal iron, all of these things, they allow thermal energy to move very quickly through them. So they are called conductors. And insulators are the opposite. They don't allow thermal energy to move easily through them. So they slow down the transfer of thermal energy. So like using a styrofoam cup when you are holding a hot beverage, that's good because it's going to slow down thermal energy from the hot beverage from reaching your hands. And the reason why some materials are great insulators while others are great conductors it's because it depends on how easy it is to make the particles of the material vibrate. So for materials that are great conductors, like the metal pans, the reason why they're good conductors is because one high energy particle can easily bump into the neighboring particle and start to vibrate. So if you imagine air, the reason why air is a good insulator is because in air, the particles are spread really far apart. So if the particles are far apart from each other, it takes a lot more energy for the particle to move and bump into another particle. That is why things that have a lot of air pockets or air-filled materials are great insulators. So imagine like cotton or feathers or even foam. All of those are great insulators. And we learned that we can keep your water bottle cold by surrounding it with an insulator like wool. You can keep your body warm by surrounding your body with a scarf that's made out of wool, because all of these things, they slow down thermal energy from leaving your warm body or from thermal energy from entering the cold water bottle. And then also we learned you can put insulators in your houses to slow down thermal energy transfer in and out of your house. And that is it for our review for today. So right now you're going to go ahead and open the study guide. You have to open up the study guide, students, because in the study guide, I updated it with all the information that you need for Friday's test. So as long as you really study these words, you can read the word, the notes, the videos, you can study all of these things on the study guide, and you'll do so much better on your test. So I'm telling you once again, this study guide is going to be helpful for your test. So please read everything and study them. You can do one page at a time. Take your time and study and read everything. And if you want to rewatch the videos, they're all linked over here. And the study guide, you can also find it in the black folder. It's the Unit 6 Final Test Study Guide. Alright, so now you are going to be ready to do your practice homework number 2. Again, you can practice up to 3 times. Make sure that you look at the study guide and do the practice homework slowly. Take your time. If you don't like the score that you get on the first try, then do it again. You have 3 tries. I want to see everyone trying until they get an A. This right over here. Don't give up. If you didn't get an A the first time, you have 3 chances. Now the password for today's homework, the password is practice 2. So since this is our second one, you're going to write practice and then just put the number 2. There is no space in between. Just write practice and then the number 2. So just like this, there is no space in between them. So again, you're going to click on this and go ahead and read the directions, rewatch this video if you want to, and then you can take your homework practice, okay? 3 times if you need to. Alright, I will hopefully see you tomorrow at our Zoom meeting if you can make it. Please join us. We'll be playing a live game on Quiz-Is. Otherwise, please practice and study for your test, and then I will upload your test on Friday.